Hello and welcome back to Aerospace and Mechanical Engineering Lab course, Lab 2 course. Today we are going to talk about the second lab in the Lab 2 series. This is the Digital Image Correlation Lab, DIC lab. In this lab, we are going to learn about field measurement of a strain specifically. So far, we have used a strain gauge, we have used an extensometer to measure the change in length or a strain at a specific points, right? A strain gauge, you install it on a beam, you install it on anything you want to install it on, and it gives you the strain at a specific point. The same is true for extensometer. But today we are going to learn about the method that is going to help us measure the strain over a field, right? Essentially, you are going to have infinite number of strain measurements that will give you a lot more information, that will give you a lot more freedom to do your analysis, to understand the structural integrity of a specific plate or a beam or whatever you are working on. And the method we are going to use to the field measurement is called DIC. DIC was developed in this department and is actually one of the high points of the department, that we have developed a method that is used worldwide for the field measurement of a strain and a stress. So the device that we have is a very simple device. We essentially have two cameras here. This is the educational version of the DIC device, but it works the same as the regular version. Two cameras are going to take some pictures of your sample as you increase the load, or as you do a tensile test, as you do whatever that is that you're doing, and it will compare each image with the previous image and gives you, it can calculate the movement of each point in your sample. Well, there is a couple of preparations you need to make to your sample and to your device itself before being able to measure the strain in the field, right? And we have the sample right here. We have to make sure that it has a pattern on it. It's called the speckle pattern. So we usually use a white background and we usually create a small dots on it. So what happens is when you take the picture, the software, which is called VIC-3D or VIC-2D, is going to follow each of these points. And based on how each of these points are moving, it's going to tell you how much a strain you see at a specific point, right? So that is how the sample works. So whatever sample you're working on, you need to make sure you actually create a speckle pattern. The samples we have in the lab are already prepared, so you don't really need to worry about that. But in future, if you're doing this for your research or you're doing this in a company, you have to make sure you actually create a speckle pattern, right? This is for the sample preparation, but for the device and software preparation, we need to make sure we do a calibration. These calibration panels come with the devices themselves. The one that we have here is a 14 millimeter calibration pattern, and it has a couple of dots here. As you can see, these dots are 14 millimeters apart. So what we're going to do is we're going to take a couple of pictures from this, as much as you need. Usually 5 pictures are fine, and that is I put a strong emphasis on usually. A lot of times you need to take more than 5 pictures, right? With this, and then using the 15 millimeter, 14 millimeter, I guess, measurement that we already have, we are going to tell the software that these are 14 millimeters apart. This way, the software is going to know how far apart are your speckle pattern, or your speckles on your sample. Okay, so a brief introduction. This lab does not need any specific measurement or calculations after the lab. Essentially, the only things you really need to do is to make sure your device is calibrated, and we're going to see how to calibrate the device. And then you have to add a couple of different loads to your sample. You have to take pictures, and you have to give us heat maps of a strain. Essentially, the only thing you really need to do is to make sure that your device is working as calibrated, and report the calibration data, and also give us the heat maps for the strain. Let's begin the lab. So the first thing we want to do is to make sure that our device is calibrated, and we're going to use the panel that was provided by a company to perform the calibration. So Your first step in the calibration is to make sure that all of the device is connected and the software is licensed, which is something that will be taken care of by your TA before the lab. The software that you want to use for taking the pictures is called VIC or VIC Snap. And then we are going to take out all of these pictures and import them in a different software called VIC 3D to do the analysis. Okay, let's take the pictures. The first thing you want to do for the calibration, I guess the second thing you want to do after opening the software is to choose the speckle or calibration pictures. It gives you, the software gives you two different options, speckle and calibration. And you want to make sure for your calibration pictures, you choose the calibration option. And then it gives you a different menu in which you have to select the grid that you want to use. Right? The grid that you want to use is a 14 millimeter grid that is 10 by 14. Meaning that it has 10 dots here, 14 dots here. Right? It's a 10 by 14 calibration panel. I'm going to select that, and then we are ready for taking the pictures. So you want to make sure that when you're taking these pictures, you want to make sure that it is the panel is far enough and the exposure is correct enough so that you can actually see the white background and the black dots. And there are 3 hollow dots on the panel. You want to make sure these 3 hollow dots are present in both pictures as much as possible. So we have 2 cameras. They're essentially taking 2 pictures. So you want to make sure that one of the pictures captures the whole panel, and the other one has the 3 hollow dots in it as much as possible. So let's begin the image capture. There's a capture button. I'm just going to capture option. I'm going to click on that. We have captured 1 image. I'm going to move it to the other side a little bit so the panel is inside the other camera completely, and hit capture again. Then you want to, I guess, turn sideways to take another picture. Again, move it to the other side a little bit so it is completely in the other camera, and select capture again. Then you want to change the orientation a little bit. Yes, we need 2 people for this. I'm going to hold on to this as much as I can, but you want to make sure you actually get help from your TAs. Hit capture again, or your teammates, I'm sorry. Move it a little bit. So my hand is in the picture, which essentially tells me that our calibration score is going to be a bit lower than we want it to be, but it is all right because I'm doing this on my own, which means that we might have some difficulty. I think this should be enough number of pictures, meaning that we can take these pictures and send them to the software, the VIC 3D software, to do the calibration. But if we don't get the good calibration score that we want to get, we always have to come back and take more pictures. Okay. So I have the calibration images. I don't need to do the calibration now. I can just take the pictures of my experiments. It has to be at the same distance as the calibration panel. So I'm just going to move it to the same location. And you want to make sure that this is in the, at least in one of the, it is being seen at least in one of the cameras as much as possible. And what we're going to do is we're going to put this on top of our sample. I can see that on my picture right here, one of the cameras actually sees the sample, all of it, but one of the cameras sees most of the sample, which is fine because we are not going to do the analysis on all of the sample. We are just going to select a part of it. And then I'm going to change the option from calibration to speckle, and we are going to hit capture. The first capture is without any loads. Then the second one is going to be with the loads, we are only going to use the half a kilogram loads. So I'm going to put it on here. That is the first load. Hit capture again. I'm going to put the second load. Hit capture again. You want to add up to five loads. So I'm going to add the third one. This is not designed very well, meaning that after the second one you might get into a little bit of trouble, but it should be fine, stacking things on top of each other. Second load, capture the image. Third load, and I'm going to stop at the fourth load. We have all of the pictures that we need. We actually have 4 to 5 speckled pictures and 8 calibration pictures. I'm going to go to the Victory software. I can go to the Victory software using this option right here. So we do not need to close the software and go to the Victory software. We can just open it from within the Vic Snap. Okay. As you can see, all of the speckled pictures and the calibration pictures are already imported. We don't need to import it from any location. So the first thing that you want to do is to actually calibrate your device. To do the calibration, you have to come to the calibration option here. Okay. So the error I got is not enough points extracted. Let me actually select all of these images and run the calibration again. So not enough points are extracted. If this happens, what you need to do is to go back to the, close this first of all, go back to the Wikisnap and take more calibration pictures with the same 14 millimeter grid. Okay. We went back and redid all of the pictures to make sure we actually have good quality pictures for the calibration. And then when you click on the calibration, as you can see, we were able to actually calibrate the software. And the data that I want to get from you is actually this value. This value needs to be reported. This whole, if you can report all of these values right here and the value, the score value for your calibration, this is what you need to report. You actually hit accept and we have the calibration that we needed. The next part would be to do the analysis with the images. So what we need to do is to make sure we actually have a good selection. We don't need to select all of the sample. We can just select some of it. When you have the selection, you should be able to go ahead with the analysis. These are the speckled images that we want to analyze. There are a couple of options that you have. You can change the mathematical model that you are using to do the analysis. You don't really need to change any of these options. The threshold, you can change the threshold. You can actually change the post-processing, and you can have a multi-option analysis, but there is nothing you need to change in the options. You can just make sure that your images are imported and click run. Okay, so we have finished the run. You can see the number of points that are captured, the time it took for the analysis, the iteration it took, and the error we have in our analysis. Okay, so I can come here and click a strain. It gives me the strain value for each of the steps. I have all of the 5 steps here. Can hit start, and it gives me the strain value at each point. You can see this is the plane that we have, and the changing colors identify the changes in a strain. You can actually calculate the strain for each part, as you can see. And this is the data I need you to report. This specific heat map is the data I need you to report for all of the speckle patterns. So when you have actually calculated the strain, what you can do is you right-click on it and save the image. It saves the image as a PNG file. You can just number it as the step that it is, and you have saved your image. You can put this in your worksheet and just submit it. So essentially the submissions you need to do is the strain values and the score of the calibration. Okay, so this was a somewhat simple lab as far as the preparation and as far as the worksheet goes, but the lab itself and the calibration on all of the speckle patterns and taking the pictures might actually take you a little while. Our goal in this lab is for you to learn how to do field measurements of a strain and learn how to do the DIC image analysis. And please let us know if you have any questions. Your TA and I will be available to answer any questions you might have, and see you in the next lab.